So, network types. Network types is kind of a broad type subject. It can mean many things. But in our world, what we're going to discuss is some different terminologies that we would use on a regular basis. The first one we're going to start off with is PAN. Now, what this means, now there's a lot of acronyms in CCNA. I mean, a lot. And you're going to find that even in your CCNP and CCIE, there's a lot of acronyms as well. But when you're getting into CCNA training, it's so many that you have to learn that it can become cumbersome. So what is a PAN? The P stands for personal. And the A and N stands for area network. So the word area means really the area that you would normally have this in. So if we have a personal area network, that really means that it's personal. It's between you and you. I mean, that's really what it means. It's your network. Now, this can mean a lot of things, but the idea of what we want to emphasize here is that the personal means something that's very close to you. So a personal will be you and your cell phone. Bluetooth. Bluetooth is a technology that is personal. You hook up your earpiece, you use Bluetooth to communicate with that earpiece, and it only has a very short range. We have earphones that can be used as Bluetooth as well. You can hook it up to your computer, and you can walk around your house with Bluetooth earphones. But again, there's only so far it can go. Now, PAN is not something you're going to see often. And in fact, you probably never hear it again in our course. LAN. LAN stands for local area network. Now, this is a big one, because local area network is technically how you define it. Now, what do I mean by define? Anytime I use the word define, it means definition. How do I provide a definition for local? If you are defining this word, it can mean anything. Seriously. I mean, here we would consider traditionally a local area network is a network in the same building. Some consider a local area network being on the same subnet, being on the same network. Some feel that local area network is anything that we can get to within a walking distance. Which means you see that you have this connection here with this router and this WAN connection going across, this serial connection. What if we didn't have this? What if this was just a router that was plugged in right across the street or right next door? You know, we would have to come out the building and walk across the street and go into this building. Some people consider this still local, both these buildings. They're local to us. So this is identifying where our locations are. Local just means is local to us. Now, ideally, local also means, it can mean several things to other people as well. Local, some people define local as using Ethernet. It's local to us, so we're using Ethernet connectivity. So anytime you say, well, you know, we need to do some work on the LAN, everyone just automatically thinks, okay, we're dealing with switches and we're dealing with nodes, and that's it. That means no routers are involved. So this could mean to someone that the local area network is something where it's all layer 2 communication. So because of that, this definition of local area network is pretty much kind of a wide range. It can mean several things. Ideally, think of local area network as really the definition of something being local to you. It doesn't mean that others who have this type of different definitions of the local area network that you can't adapt to those. When someone says local area network, you might have a different definition of it. You've defined the word local in a different way as someone else has defined local. But nonetheless, you know the word exists. And because of that, you should be able to ask someone, well, when you say local, are you talking about just layer 2 traffic? Or are you talking about the entire building? A question like that. I mean, that's a really legitimate question. All depends on how someone defines it. WAN. Now, this is pretty self-explanatory. Wide area network. This means we have a connection that's across a wide area. Now, think of these two IPs connected somewhere down the line. And this was not here. And this was in Texas. And this was in Maryland. Well, you do have this connection going to the internet, coming across, and you have a peer connection between these two sites. Maybe that's not the case. Maybe you don't have these links at all. And maybe you just have this leased line or this long cable that's going from one side to the other. And this will be your WAN, your wide area network connection. Or maybe you do have it just like this. You have a connection between your two routers, and you have your connections to the internet. And I can communicate from Texas to Maryland between this link right here or through the internet. But the second that we are going outside our building, outside our local area network, when we're leaving our local area network, we are transitioning into the wide area network. Does that make sense? So wide means long range. Hence the term WAN, wide area network. Now, MAN is pretty much the same as wide, except it's saying that we're not just doing wide connections. We're going from metropolitan to metropolitan areas. Hence the word MAN, Metropolitan Area Network, which means we're connecting two metropolitan areas together via this particular, however we're going to connect them, whether with one link, several links, but we're going from one metropolitan area to another. Now, this concept of the cloud is something that you're going to see a lot because the cloud always emphasizes the internet. That's how we see the cloud. And the word cloud is thrown around all the time. I mean, it's thrown around so often that people who don't know the word cloud just use it as everyday conversation. Well, where did your traffic go? Oh, it went somewhere in the cloud. Well, that's not really a good explanation. However, this is what people do on a regular basis. It's in the cloud somewhere. Who knows? That's where it went. Nobody understands the cloud, right? Well, the concept of the cloud is you do understand the cloud concept. You just don't know what's in the cloud. And that's really what the cloud means. It means that from here, everything that I have in this diagram, I know about. Either I control it, I know it exists, but I know what it is. When my traffic leaves this router 1, and goes in through this interface, it hits this cloud from this end. I might know about this end, but anything past this, I have no idea what it is. So this might be your ISP's router. This might be router 2 sitting here. And you don't know how router 2 is configured, but you do know the IP address of this router, and that's it. And in this cloud could be thousands of routers that it would take for you to get to your Texas site over to your Maryland site. So I could draw the cloud like this. instead of having these two, I could just have one big cloud, or I could draw it like I just, like I already had it, two separate clouds. But the cloud means we don't know what's going on in there. So like a VM, give you a perfect example. The last video I did, I had 3 PCs. PC 1, PC 2, PC 3. To you, each one of these PCs are individual, but that's not what these were. These PCs were nothing more than well, not even real devices. I mean, they're just what's a good word? I'm trying to think of a good word to explain it. I guess the best way to say is it's a piece of software making you believe you're sitting on hardware. That's the best way to explain it. Because I could say it's a piece of software, but isn't that what Windows is anyway? Because I have Windows 7s on all 3 of these machines. And they all sit on this server here. You're accessing them as if they're 3 separate machines. To you, they look like they're 3 separate machines. So when PC 1 wants to communicate with PC 2, what would it have to do? I mean, technically, when you're sitting on PC 1 and communicating with PC 2, it makes you believe that you're directly connected to those devices. When in reality, this is really what's going on. Somehow behind this communication, we have connectivity, but we don't know what that connectivity is. We might think we know because it makes it makes it look like that. But technically, this is how we draw it. The cloud symbolizes that we don't know. And that's really the big thing with the cloud. Devices that we have on our land. Now remember, our LAN is our local area network, and we can define that land as a sense of area where it's located. The fact that we're just using layer 2. And based on what I'm going to explain to you now, you might get down to that understanding that, well, this really LAN means layer 2. Because the devices that we have on the LAN all work on layer 2, including this router. And we're going to see how. So our first LAN device is a switch. Now, we know switches are used to connect multiple devices for communication purposes. So if I connect PC 1 and PC 2 here, they will be able to communicate between each other without any problems. Now, that's nice because if I have a 24-port switch, I can hook up 24 devices, and my network is starting to grow. Now, we also have this router sitting over here, and we all know that this is a layer 3 device, and this switch is a layer 2 device. But we need to understand, as we were looking at our last video, the layer 2 and layer 3 information must be built. And this router here, this interface is a LAN interface. It might be a layer 3 device, but it's connected to our local area network. Now that's a little weird because I could have another router sitting over here and have it connected to my local area network and even have a connection between them. These are still LAN interfaces. It's not until I leave my network in some fashion will that traffic be moved by layer 3. So anytime my traffic is going up to this router, and between here, we're really doing layer 2 communication. Technically, between the two routers will be layer 3. Whenever you're communicating between two routers. But remember what I said before. I might be sending traffic from router 2 to router 1. However, I must build the layer 3 information, encapsulate that with layer 2, and the destination MAC address, as is coming from router 2 to router 1, better be the same, which means this destination, this needs to be layer 2 here. So this layer 2 information, this destination MAC, needs to be the MAC address of router 1. If it's not, router 1 is going to drop it. This is where what I was saying earlier might be a little confusing to others when I say we might be using layer 3 to make our forwarding decisions, but we still have to build the layer 2 information when we're routing between routers. I still need to have the layer 2 information. And that layer 2 information must be the correct one going to router 1, or else router 1 is going to drop it. If this does not happen, I can't send the data. And what you're going to get is an encapsulation error. It'll say encapsulation failed. If my ARP table's messed up, that'll happen as well. I'm sorry, but I don't have anything in ARP. The ARP request isn't working. For whatever reason, it's not working. If I don't have the destination MAC address, I can't finish building my layer 2 information. Therefore, my encapsulation failed. So because of this is all still LAN devices. I have a LAN switch, I have a LAN interface on my router, and I also have WAN connections on my router. And I have this LAN connection between these two, which means even though these are two routers and they're communicating with each other, they're still on my LAN. So you can say that LAN traffic just deals with layer 2, but in this scenario, it's not. It's dealing with layer 3 as well. That's why sometimes you have to ask people questions, ask them to be specific, because in somebody's mind, they're not looking at it that specific. They have it in their mind. This is what layer 2 traffic is. This is what a LAN is, and it's not really 100% clear to them, but they think it is clear to them. Now, we also have this interesting thing called a hub. Now, this hub is also a device that can sit on our LAN. However, a hub, no matter what is happening, a hub is just a means of connecting PCs. There's no intelligence with the forwarding decision, which means every PC that is sitting on this device will get the traffic of every other PC. Where a switch, that's not what a switch does. A switch will only send the traffic to the ports that it belongs to. Now, based on that, if PC5 sends traffic going in this direction,